It is already 35, so we will start the session. And there would be some interruption today because I need to admit like one by one. Somehow that extension is not working. Yesterday I hard reset the Chrome browser, so that's causing the issue. Ah, not this one. Oh, where it is? Bigo recursion in DP. Not climbing stair. Ah, this one. We forgot yesterday actually. Huh. This would be more or like straightforward today because we have solved tough questions yesterday. So it would be like more like a straightforward thing. But before starting that, let's look on. Let's have like bird eye view on this thing, on the formulas that we have. Uh, where is the note? Notes. Yes, this notes. Okay. So we saw this like notations like day before yesterday, and at that time I mentioned that this linear search versus binary search, this longest common subsequence, and that matrix multiplication, and we have one more something called subset sum problem. We don't have any, you can say, numericals based on this, but it is a special class, complex class algorithm, that it is exponential time only. Currently there is no algorithm known to solve it in less than exponential time. So it is complex class algorithm, to be said, right? So let's see these formulas and have in like intuitive understanding of the formula, because like what I have observed is they can ask the formula in different format, same formula but in they can write in different format. The essence would be same, the meaning would be same, but they can write in different ways, right? So the first thing is the search operation. What search operation is, given the array, I guess my screen is visible. Yes, I am sharing the screen. Given this array, 1, 3, 7, 9, it can be any random array. It could be sorted or not sorted. Right? For binary search, it should be sorted. But for linear search, it is like possible that if it is not sorted, we are fine. Now, given array, we want to find out some element, right? Find 7 if it is there or not, right? So our problem is to find particular element out of an array. Now we can do it linearly, right? Always like what we will do. We will just check the number one by one. If it is there, then we can say this element is found, right? So what we are doing is we are checking the element one by one. What would be the best case? Best case would be the element found at the first place, all right? So it would be order of 1. And what would be the worst case? If element is at the last in the queue, then we will checking all the elements one by one, and at last we would be able to find out that element, correct? So it would be order of n, because we are making comparison operation n times, right? So this is linear search, boring stuff, and order of n not good. Now, given a array, sorted array, huh? It is a very, you can say, star condition for binary search, that the array is sorted. Now what we need to do is, and see, if array is not sorted now, then there is a like no sense to use binary search at all, right? Because any given sorting algorithm will take like at least order of n, right? Or n log n, correct? Insertion sort is n square, merge sort is n log n. Another sorting algorithm I don't know, but it would be at least order of n, right? Because without visiting all the elements, you can't sort them, correct? So if the array is not sorted, go with linear search. There is no problem. But if the array is already sorted, then we can use the binary search. And what is the idea behind binary search is, let's say I want to find out one number, let's say 7, correct? Now I know my array is sorted. So what I will do, I will directly jump onto this location at half, right? I will divide my array in half. If it is you can say even number array, then it is easy. But if it is odd numbered array, we can manage it, right? 4 and 5 element like that, taking the floor and everything, right? We can take the floor value, and we can divide there in 4 and 5 elements. So what it is saying is, just come at the middle location, so the iteration one. Then we will say, if like which side I should go, right? I'm finding for 7, right? So if I go to right side, there is no chance that it would be 7, because on my right I'm having 17, and on my left I'm having 9, right? So all the elements on the left side would be 9 or less than 9, and all the element on the right hand side would be 17 or greater than 17, because this array is sorted, already sorted, right? So I'm at middle position, and now I know like which side I should go, right? So I just literally discarded my half array, right? So I want to be using these 4 elements anymore. I know like my element is somewhere between, somewhere on the left side. Now what I'll do, I have 4 elements, so again I will jump onto the middle location, right? And at this middle location, what I'll do, I will check what I'm having on the left and what I'm having on the right. So on right I will find out the 7. On right I'm having 3, so it is not possible that my 7 would be on the left hand side. So at each iteration, what I'm doing is I'm dividing my array into half, right? So this is kind of, you can say, dividing your work into half at each you can say step or iteration, right? Because the array is sorted, so it is trivial. And say, going into that location, that half location is order of 1, right? Because you see, you know the length of the array, just divide by 2, so you know like which is the middle location. Again divide by 2, so you know the like next middle location which is, right? And just add it or remove it based on like on which side you want to go. If you want to go to right side, just add n by 4. If you want to go to left side, just divide minus n by 4, like this. R equal to m minus 1 or L equal to m plus 1, like this, correct? Okay, now what would be the time complexity of it? So if you think intuitively, what we are doing is, at it t of n is nothing but t of n by 2. That means we are dividing our work in half, n by 2, and I am performing some operations. These all operations are order of one, right? Assignment operation, if condition, right? So it is order of one, order of one, order of one, order of one. So let's say I'm having 10 operations for safer side. So 10 multiplied by order of 1 is nothing but order of 1. Correct? So it is nothing but 1 day. Tn equal to Tn by 2 plus 1 day. And now we know from the back substitution method what we will do. We will substitute the value of T of n by 2. Right? So technically this will take n log n for sorting and log n for searching. So it would be n log n. Yes, definitely. But n log n is greater than order of n. Correct? So if the array is not sorted, there is a doubt. Like technically, this would be n log n only, right? Because sorting the algorithm will take n log n time, and finding the element will take the log n time. So the my total time complexity would be n log n, but it is greater than order of n. So there is no sense to like sort the array if you don't need it, right? Because in most of the case, the sorted array will be very useful, correct, in reporting or anything, right? Which cab is very near to me. So every time I am interested in sorted you can see information. So if there is no need, just use linear search. There is no problem with linear search. Order of n, we are fine. But if the array is already sorted and you need the sorted array, just sort the array and like have this like enjoy this complexity, time complexity of log n, right? Because log n is way better than n. Correct. If you take 1,000, then it would be like order of 1,000. So it would like perform 1,000. You can say computation, right? 1,000 unit of time. And if it is log, and then it will just take the 3 unit of time. Base given base 10. Correct. So let's see how to use the back substitution method just for the revision purpose. So t of n by 2 I can write as t of n by 4 plus d. So t of n by 4 plus d plus one more d there, it was there, so d plus d would be 2d. Now I will again substitute t of n by 4. the value of t of n by 4 would be t of n by 8. Just divide whatever the value we have by 2. So t of n by 4 divided by 2 would be t of n by 8 plus d plus 2d would be 3d. So now we know, like from first equation, first iteration or first recursive call, it is n by 2 and 1d. In second iteration call, it is nothing but n by 2 square plus 2d. Third iteration call, n by 2 cube plus 3d. So at kth recursive call, it would be n divided by 2 raised to k plus kd. Now, when this iteration will stop, when we have just one element left, right? If there is just one element, then it is nothing but what we are finding, right? So if you are finding for 8, there would be last element called 7. Now we know, like 8 is not there in the array, right? When the last element, the number of elements in the array would be 1, then we will stop. So it is nothing but n by 2k equal to 1. So 2k equal to n and k equal to log n. So I put all the value here. So t of 1 is nothing but c, k equal to log n d. So it is nothing but order of log n, right? I'm not going much into detail because we solved like very tough, and you could say that geometric progression based uh, this numericals also. So this is like a toy example now. Okay, so this is one problem that we have. Like we can solve this linear search using the binary search with the log and time complexity if the array is sorted, right? Let's see one more problem, and see, every time recursion is not you can say silver bullet, right? It will not kill every, you can say, everything, right? Now if you are solving this Fibonacci number, right?
My
And
sorry
yes.
to interrupt you.
No,
So
no.
here, like, I'm confused. Like, when do we need to add 1 plus 2 plus 3 plus so on till log n, and when do we need to consider only the last term?
Last time
Sometime.
I didn't get you.
So here sometimes when we are calculating the time complexity, we for some cases we will be adding 1d plus 2d plus 3d and so on up to log nd, and then find the series, right? So in
Huh.
what cases we do that, and in what cases we directly take the last element like log
No.
nd?
Yes, 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 yes. No, I understand the doubt. It will,
Yeah,
if there is a series, na, the series will
yeah,
come up already. See, if I take one example, when that series will arrive,
yeah.
uh,
Sometimes we add all the constants to arrive
huh,
at the
yes,
series,
yes,
right?
yes. Nee, I understand. See, sometimes what will happen is you won't find this kind of, you can say, relation. At first iteration is 1 into d, second iteration it is 2 into d, like that.
Hmm.
So if you are not
Yeah.
able to find that, let me take one example already. This is, let me have one more. This example let's take, or I
Oh,
guess, okay, this example is good. Now, what will happen here is, at first iteration, you have 80 n by 2 plus a, right? Looking very similar, t of n by 2 plus d,
yeah.
right? But I have just one, you can say, multiplier 8 here. So I am doing 8 n by 2 task. Now, what will happen is, if I take the second recursive call, then it is coming something like this: 8 square
Yes.
t of n by 4 plus 9a. So how can you can say decode this, that at second iteration I'm having 9a, so you can decode it as 8 plus 1, 8 to the power 1 plus 1, right?
Okay.
And see, it would be very, you can say, and if we go one step further, third iteration, so I prefer to go up to 3 steps so everything is clear. So if I go to third step, it would be 8 cube t of n by 8 plus 64 plus 9, right?
Okay.
No,
Yeah.
73. So how would you decode 73, right?
Yeah.
So if something is in multiplication and it is increasing like anything, then it is
Yeah.
better to write this kind of notation, not 9a, just write 8 plus 1.
No, no. Actually, my question is like here in the end we have t of n series in the terms of n by
Huh, huh,
n by 2 power k, right?
huh.
So here n by 2 power k is one. Like we
Yes,
take it as one. So
yes.
we got the value like k is log n.
Huh.
Now like okay, now I get. Okay,
Yes,
the
if you
series
put
is
log
coming
n, then
from the
it would
before
be
term.
it would be
Okay,
like
okay,
it would be very tough. 8 to the power log n minus 1 log n minus 2. So better to solve this
okay,
series first, and we got this really, you can say, small step, or you can say simplified version, 8k minus 1 and 8 minus 1. So we can deal with it. So 8 to the power k is nothing but n cube, right? And
okay.
and there is no meaning to write 1 plus 1 1 plus 1 plus 1 here, right? Because we
Yeah,
can directly say it is just the multiplication of whatever the step we are. If it is third step, it is 3d. If it is kth step, it's kd. Correct.
okay.
But here it
Yeah,
would no make no sense. At first step I'm having 1, second step I'm having 9, at ninth step I'm having 70 to 73, na? So
73.
answer no, 30, 73.
Yeah.
Correct.
Okay.
So how
Yeah,
can you generalize that for kth step? Right. So it is kind of like this that question we get in aptitude reasoning. We just
okay.
break down the
Yeah, yeah.
logic. Correct.
Yeah, understood now.
Sure.
Yeah. Thanks, Mahir.
No problem. Any other doubt, guys? So this is completely informal session. To feel free to like pause me at n divide. I just say n divide and just feel free to pause me. Don't wait for me to like complete the topic and then ask. Right. Okay, so let's see, like, and see the recursion is kind of like there is a very big debate also, just off topic, that the founder of Python, I just forgot the name, is not very fond of recursion. So like compared to other algorithm, Python is not supporting so much of that tail what it is called, the tail call recursion and some other functionality like high level functionality Python is not supporting, because you don't like recursion, because sometimes it is yeah, sometimes it will make your program very much hard to read sometimes, right? And even debug also. So, and it is not silver bullet every time that we were left. So if you solve this Fibonacci number series, right, using recursion, then it is order of 2n. Correct. And I guess we had like one complete session on recursion only. We wrote the program like based on recursion, dynamic programming, having some memoization and everything, and iterative also. I guess the notebook is available on my GitHub repo, that recursion will make so many call 2 raised to n. So it is order of 2 2 to the power n. And if you solve it using simple iteration, that given term is nothing but the summation of last term and second last term, then it will be just order of n. And if you use the dynamic programming based like use, we are writing recursion program, but we are saving this already calculated, you can say, value, then it would be order of n. And there is no point like going into programming right now in for the Fibonacci number. Let's take last three, or basically last two methods in the dynamic programming. And dynamic program is nothing but we are just improving this, you can say, this subset of problem, repeating subset of problem, using some methods called memoization or graphs or some structure, data structures, or simple metrics, right? So we are saving what we know. And dynamic programming is deep is also called as like dividing your program, or you can say problem into smaller pieces, right? So if we don't know like what is the cube of, let's say, some big number, right, or some factorization of some big number, then we will start from the zero. We will solve the small problems, and then we reach to that point, right? uh, Having said that, let's see some problems that we have in our, and this was asked also, right? This longest common subsequent sequence problem, that was there, I guess, in mid sem also. We were given this kind of two strings or two array we can have, or two strings, array or strings, and we want to find out the longest common subsequence. So it is nothing but let's have our beautiful tool, paint. So it is nothing but let's say I'm having A, B, D, C, G, H like this, and another I'm having P, B, C, H, D, G. I'm having something like this, and I want to find out the longest common subsequence. Right. So I am interested in finding the sequence which is common in both. It should be in the same order, right? And it should be the longest between two. So it would be nothing but B, C, G or B, C, H, right? So it could be B, C, G or B, C, H, right? Like this, correct? So or B, D, G also. Okay. I completely forgot about that, right? So this is the problem that we want to solve, and see, this is a really small, you can say, problem. That's why we are doing able to do this, and still we are am making some mistakes, right? So there should be some, you can say, mechanism or algorithm how to solve this problem, right? How to solve this problem, right? So now what we are doing is we are dividing this problem into sub problems, and we are writing one. Yes, Karthik. Hello. I'm not able to hear you if you are speaking. Hello. Okay, I guess we have lost him. Okay, you can type the question if audio is not connected. Okay, so and see, this is the equation actually. After doing all the research and how to solve it, and after you can say making like matrix like structure, and there is a really good example in course video that sir literally made one matrix taking two strings and try to solve it using this formula. And if you observe in that matrix, we are having couple of one zero and two like that, and using those value and backtracking, we can literally find the longest common subsequences actually. More than one subsequence also we can find using that matrix, but without going into that technicality. And definitely we are not going to use this formula, right, while solving this thing, because we can solve it like without using the formula like this, right? Just go from the like any one side, take the common terms and take all the combinations. But this formula is really useful, and let's see what this formula is saying. So this formula, I will just read it once, and then I will try to explain it. So what this formula literally saying is longest common subsequence of m minus 1 or and n minus 1. M and n are nothing but a total number of terms, right? I'm having one array or string x. It is nothing but 0, 1, 2 up to m minus 1 terms I'm having, and y is nothing but 0, 1, 2 up to n minus 1. So n minus 1 time terms I'm having in the second string. So in this case it would be 1, 2, 3, 4, 5, 6. And what happened? 6 here, and again 6 here, right? So what they are saying is longest common subsequence of 6 comma 6 is longest common subsequence. I'm writing the problem again. M minus 2 n minus 2, that is nothing but the second last term and second last term, plus 1. I'm increasing the count, right? So this is nothing but the length. We are finding the length basically. So it is nothing but length of longest common subsequence. So plus 1 if, what is the condition? X of f m minus 1 is equal to y of n minus 1. So let's see what this formula basically saying is. Let's say I'm having two strings, uh, m n o p q, and another string I'm having is n o r s q, right? Now what happened is, uh, Now what they are saying is the longest common subsequence, the length basically, is length of longest common subsequence of m minus 1 comma n minus 1. So it is LCS of 1 2 3 4 5 5 comma 5. So I am solving the problem of 5 comma 5, right? It is nothing but I need to solve the problem for 4 comma 4 plus 1 if the last two elements are similar, right? Last two elements are similar, correct? So this is the, you can say x, this is y, right? So x of f my m minus 1 is equal to y of n minus 1. So this is the case we are having because this q and this q are similar, right? If we want to find out the longest common subsequence, the length of longest common subsequence, then what we are doing is we are going from the backward direction. If we found that these two are similar, right? If x of m minus 1 and y of n minus 1 is similar, then I am increasing my count by 1. So I know like it is for sure 1, right? Rest I don't know. I will solve this problem, LCS of 4 comma 4, right? And how will I solve it? Again I will apply the same formula, right? So this formula is not over yet, right? If it is not over yet, now what I'll do, if it is common then plus 1, right? So I know for sure that it is plus 1, at least 1, right? If nothing is matching, this q and q are matching, right? So I can discard this. So I'm discarding this and I'm just taking 4 comma 4. So 4 comma 4 is nothing but 1 less than this. So m minus 1 is m minus 2, n minus 1 is n minus 2, right? Any questions guys for this case? We are having just two cases here. So any problem with this first case? Any doubt guys? Because if you don't understand this na, then mugging up the formula is a challenge also. If you understand it, there is no problem, don't need to mug up, right? Okay, now if this is solved, then I again I need to solve LCS of 4 comma 4. So let me write it separately. So the problem in hand is LCS of 4 comma 4. Now this case will be not there, right? Because P and S are not matching. So problem I am having currently at hand is MNOP and NORS. So what I need to do is I will take LCS of max of, so I will take the max of count of, I will solve MNOP and NOR. So what we are doing is we are holding this P and we are finding if we are able to find P or not. So P and S are not matching, right? So no need to match P and S, right? Because this is see, if P and S are matching, in this case Q and Q are matching, then this case would be there, right? And we are checking for the second case, and what second case by default is the last element is not matching, correct? Last element is not matching. So what I will do, I will check, I will try to find out P here. If it is not there, I will try to find out P here, then I will try to find out P here, right? So currently the problem in hand is I will solve MNOP and NOR. Any doubt guys, why we are not taking S? Because P and S are not matching, that we know. If it was matching, we have just discarded it and increased the count by 1. It would be the case number 1 basically. Since it is case number 2, we know for sure that P and S are not matching. The last element in the subsequence are not matching. So the first problem what I will solve, I will check M and OP, the four element LCS of, from first I will take the four elements, and for second array I will just take the three elements, right? And now see first we will see if we are able to find P or not, but again we need to find out, we need to check for S also, correct? Okay, it is removing everything. So now what I'll do, I will take S now, this element, and uh, I have big eraser. Okay, so now what I'll do, I will take S now, this later from the second last element, okay, so the last element of the second string, and again I will compare with the M and O, right? I will skip p because s and p are not matching because it is case 2 already. So I will solve lcs of 3 elements of first array and 4 elements of last array, right? And in case we find out, let's say we are solving MNO and NOR, then these O and these O will match, right? So we will increase the count by 1. Because while solving that, what I will have? LCS of 3, 2. LCS of 3, 2, I will have match. So I will just increase the count by 1, right? So this will work recursively. So this is the recursion problem we have. So let me show it again. So what I'm having currently is, and see, since we are solving 4 4, I am having 4 and 3, 3 and 4 here. If we were solving 5 5, then what would be here? 5, correct? And what would be the here? What would be the number here? 4, 1 less than that. And take all elements of second array, 1 less than first array. And similarly, all elements of first array and 1 less than in second array. Right? So this is nothing but I have written here. Right? So LCS of m minus 1 n minus 1, that is nothing but the current problem we have. It could be 5 5 4 4 4 3 3 2, anything. Is nothing but increase the count by 1 if we have found the match. If there is a match between these two elements m minus 1 and n minus 1, just increase the count by 1 and discard those elements, right? Discard q and q because we have found the match. So your problem is reduced to m minus 2 n minus 2. First case is solved. If it is not the case, if it is not matching, then what we need to do? We need to check the last element in the last element of one array into another, right? So we are taking m minus 1 and checking in n minus 2, right? Why not n minus 1? Because those two are not matching, that's for sure, right? So we are taking m minus 1 elements and checking into n minus 2 second array of n minus 2 elements. Similarly, we need to do it in otherwise. So we are taking this n minus 1th element, and we are comparing it with the m minus 2 elements. We are not taking m minus 1 because n minus 1 and m minus 1 are not matching. So there is no need to do the extra work, right? So this is the whole formulation. If you follow this formulation for any given, you can say strings, couple of string, two string basically, you will find the length of longest common subsequence. At the end you will have the longest common subsequence, and we have this max operation, right? Why we have taken the max operation? Because while comparing this O, if I am able to find one match, right, I will just increase the count by 1. But say this is the sub problem. Say if I solve MNOP and this NOR, and I am able to find out the two matches, and while solving NORS and MNO, I am able to find just one match, right? So which number I should take? 2, right? Because I am solving for the longest common subsequence. If it was not longest but shortest or anything, then like it doesn't make sense actually for shortest, because we just need to find out if there is any common element or not, right? So to find out the longest common subsequence, we are taking the max because we are interested in the longest sequence common between two. Send one image on WhatsApp group for better
Hey
understand.
Mayur, there is this matrix thing I was going through today.
Aha, we are going to cover that. It's planned already.
Okay, okay.
Yes, yesterday we completely forget about that mandatory exercise because it is hidden between this thing.
Yeah, yeah.
Yeah, 11 point something. 11.30. And I have even solved this thing also. So I have a solution for this also. Because this is easy to miss, but there are some, you can say, good examples in these solved problems also. 1, 2, 3, 4, 5, 7. 7 problems we have. I guess more than 7. But we have good examples over there, and it is already, I have taken that. Okay. So LCS is done, right? And the worst time complexity would be saying if nothing is matching, we need to solve two more problems. From one problem we are solving two more problems if nothing is matching, right? So at level 1 I will have 1 to 2 sub problems. Let's say in both sub problems nothing is matching, the last elements are not matching, then 2 will be converted into 4, right? At level 3 it would be converted into 8, right? Two sub problems would be of 4, I need to solve 4 more sub problems. If nothing is matching in all 4, I need to solve 8 sub problems, to each, right? So at level h or level k, I use like any funky alphabet I just come in my mind. So it would be 2 raised to h, right? So h is nothing but m plus n, so it is nothing but order of 2 to the power m plus n sub problems, right? How h is m plus n, it is common sense, right? Because if we have m, then we will take one element each and we will try to check it into n elements, and in otherwise we will take one element from each at from n, and we will try to check it in m for everything. So it is nothing but m plus n, because we need to perform this thing for every elements in m and every elements in n, so it is m plus n, right? So the time complexity is order of 2 raised to m plus n, not important with respect to exam, but good to know, right? Okay. In best case, order of minimum of m plus n. So why it is order of minimum of m plus n? Let's say I'm having ABCD, EDF, and EDF. These two are string. Now what will happen? This m minus 1 and n minus 1, basically the last term will match. So f and f will be discarded. Sum would be increased by 1. Now d and d would be discarded. Sum would be increased by 1. So my current sum is 2, and E and E would be discarded, my current sum would be 3. Now I don't have any element in the second array, so I will just discard my problem, right? So it would be order of minimum of m plus n. So if my second array is shorter, it would be order of 3, right? There is nothing in universe like order of 3 constant time, so it would be of order of m plus n. So whatever the size of shortest array is, it would be my time complexity, right? What is the time right now? Okay, it is about 10. So let's take this matrix multiplication, then we will jump on to numericals. So as per my prediction, today also we will hit 11:30 mostly. Okay. Matrix chain multiplication. So why this is important? Let's understand that. And why I'm emphasizing is because these things are very simple, but very good to know actually why we are doing this thing. So matrix and multiplication we can't see. There are so many. See, let's say I need to multiply a into b into c, and ABC are matrix of a is 10 to the 10 cross 30, 30 cross 5, and 5 cross 16. Then you would argue like just multiply a b, and whatever the answer is there, just multiply by c, right? So what happened if I do that? Then I need to I need to do the 4500 operations. But if I do b multiplied by c first, then multiplied a, then what will happen? I need to do 27000 operations, right? Matrix multiplication, you know, right? Because we need to take the all elements and multiply the row versus column, correct? So this much operations I need to do. It is nothing but 6 times, right? For simple example, just three matrix chain I am having, three matrix I am having in the chain. So there should be some you can say way, because it is not possible, right? Before and say this we know, right? What is the size of the matrix? What is the, you can say, shape of the matrix? So from the shape of the matrix, there should be some way, so that in advance I know like this is the good way. A multiplied by b, then multiplied by c, it is a good way. Then I will perform 45000 sorry 4500 operations, right? So that algorithm is called this matrix and multiplication, or you can say this optimized matrix cell multiplication. So what we are solving is we are trying to find out the chain, right? We are basically trying to find out the chain. See, and let me write the problem clearly. So what we are doing is a multiplied by c multiplied by d. If I'm having something like this, then what will happen is, see, there are possibilities. See, if I take the group of two, then A multiplied by B have some cost, B multiplied by C have some cost, C multiplied by D have some cost, D multiplied by B have some cost. Let's remove the C, E for some time, right? Then I can take the group of three also. So I can group ABC also. There would be some cost involved, and I can group BCD also. So there would be some cost involved, right? So the multiplication of A multiplied by B multiplied by C multiplied by D can be formed something like this: A, B, C. If I take the group of 3 multiplied by D, right? Otherwise, A multiplied by B, C, D. Also, there is possibility A multiplied by B, then take C multiplied by D. Also, there is one possibility: A multiplied by B, just A multiplied by C, whatever the answer you get, multiplied by D. So D. So it is same as this thing, right? And also, say, if you divide this, there are also two possibility. ABC can be done in two ways: AB then C, or A then BC, right? So what is, you can say, optimum way how to find out this, right? We cannot do it on hand, right? There should be some algorithm. So that is nothing but this algorithm, correct? So now, having said that, let's jump into formula, and then we will take one example directly of this thing, matrix in multiplication. We have two example. One was discussed in the solved problem 4 or 5, and one was there in exercise. Okay. So given Mij, right? So what is Mij? So Mij is nothing but the cost of multiplying this I and j. I and j is nothing but this thing, what it is called, row and column. Not particularly row and column. So this is what we can say this M13 MIK. Uh, so it is nothing but chain. See, if you have M1, A1, A2, and A3 like this, then M13 is nothing but multiplying A1 multiplied by A2 multiplied by 3, A3. So Mij is nothing but it is multiplication of ith element from ith element up to jth element. So if M13 I'm saying, or let's say I'm saying M46. So what is M46? M46 is nothing but A4 multiplied by A5 multiplied by A6, right? From ith element to jth element. So what is the problem in hand? I am having this A1, A2, A3, A4 up to AJ, right? So I am having from I to J, I am having my multiplication, sorry, matrix chain, and I want to find out the cost. So Mij, this multiplication cost is nothing but 0 if it is I equal to j. What is I equal to j? That means A1 only, right? If you have one matrix, what you will multiply, right? So the cost is 0 if I equal to j. Let's say if I is not equal to j, that means I want to solve A1 multiplied by A2 multiplied by A3, or anything, right? We are generalizing the formula. So if I want to multiply this thing A1, this is really, you can say, good formulation. So we want to solve this A1 multiplied by A2 multiplied by A3. It is nothing but M of 1 3, right? So I am just ignoring the first case, 0 if I equal to j, right? So this is defined something like this: minimum cost of, because we are minimizing the cost, right? So minimum cost of I less or equal to k, less or equal to j, right? What is k? K is nothing but the separation point. I'm just coming that in a moment. M of I k plus M of k plus 1 j plus P of I minus 1 pk pj. So what is this? So if I want to solve this problem a1, a2, a3, so I need to take minimum of, and this k come from I to j, not j, huh? It is I but not j. So in this case, the value of k could be, the value of k can be, how many k I can have? I and j, not j, so less than j, so 1 and 2 I can have, right? K equal to, I can have 1 because it's I less than or equal to k I'm having. So k can be 1 or 2, and k is separation point. So what is the meaning of separation point, and what I need to do, what I need to say, this is nothing but the cost, right? I am just coming it into the moment. So let's understand what is the meaning of k. So k is separation point. So how many separation point I can have? See, we are generalizing it, because if you think intuitively, how can I separate this? Either I can have a1 a2 then multiplied by a3, or I can have a1 then multiplied by this, whatever the answer I get from a2 and a3. So if I put k equal to 1, then what will happen? M of I k, that means I equal to 1, k equal to 1, that means 1 1. So it is nothing but a1 plus whatever the cost I have at a1, it is nothing but 0, right? 1 1 0 plus m of k plus 1. So 1 plus 1 is nothing but 2, so a2 up to j is nothing but 3. So m of 2 3, so this is 2, this is 3, so m 2 3, this is nothing but a2 multiplied by a3, right? So whatever the cost I have for multiplication of a2 and a3, and there is some cost, whatever the answer I get of a2 and a3, I need to multiply it by a1. So that cost is defined by something like this: p of I minus 1 multiplied by pk multiplied by pj. So we are just coming into, like I will explain this in a moment, right? So this is some cost to multiply these two things. And what happen if k equal to 2? If k equal to 2, it would be nothing but m of 1 to I is 1, sorry, I going from I, m of ij, I is 1 already, and j is 3. Okay, so I is 1, k equal to 2, so m12, what is m12? A1 multiplied by a2, right? A1 multiplied by a2 plus this thing, m of k plus 1. So what is the k? K is nothing but 2, 2 plus 1 is 3, so m of 3 comma j is nothing but 3 again, 3, m of 3 3, it is nothing but a3 only. Plus some cost to multiply these two answer, right? And this cost is nothing but p of I minus 1 multiplied by pk multiplied by pj. And what is p now, right? So many terminology, just pay like the highest attention here. Now let's jump on to this notations now. So a1 is size of p0 p1, a2 is size of p1 p2, a3 is size of p2 p3. Then only we can perform this multiplication, right? For the multiply like two matrix, the column, the number of column in the first matrix should be equal to number of row in the next matrix, right? So p1 should be equal to p1. So I am, this is repeating, right? So p0 p1 p2 p3 up to pni we have, right? So this is nothing but, you can say, shape of the matrix. If I'm saying p2, that is nothing but the column, number of column in a2, or number of rows in a3, correct? Now to multiply this to my matrix, what would be the cost, right? So if I will to multiply these two matrix, ai and aj, any matrix, any matrix with the size pa pb and pb pc. So if I have two matrix, what is the cost? Let's say I'm having one matrix of 10 cross 3, and one more matrix, it is having just 3 rows, but let's say 5 columns. So if I multiply A dot B, A cross B, A multiplied by B, what would be the cost? Anyone? It is simple multiplication that I need to do. So it would be nothing but 10 multiplied by 3 multiplied by 5.
3 into 5.
Yes? 15 dot, so 150 I will have. Correct? So it is nothing but PA, or you can say P1. So if see A is nothing but PA PB I am having, or PI minus 1 PI and P of J minus 1 J plus 1, whatever the notation we can have, huh? While writing the notes, just take Q or any W. So by taking like this kind of different notation, the you will grasp it better. Otherwise your mind will try to mug this thing, these notations every time, right? So change the different alphabets, right? So it is nothing but the cost. So now we would be able to understand this cost now. So what would be the cost of multiplying these two, sorry, matrix, right? So what is so if I generalized it, so what is the you can say for A1, what is the size? 0 cross 1, P0 P1. A2, it would be 1 cross 2, right? P1 cross P2. For A3, it would be P2 cross P3. So if I multiply by A2 and A3, the resultant would be A1 cross 3 only, right? And 0 cross 1 I am having here. So, and if I multiplied now A1 and the answer of A2, A3, it would be 0 cross P0. Actually, not 0, it is P0. Huh? As I'm writing from mouse, I am trying to be write like as much as minimum I can. So it is nothing but P0 multiplied by P1 multiplied by P3, right? So if I want to generalize it, what is P0? It is nothing but I minus 1, because 1 is I equal to 1, then I minus 1 is 0. So P of I minus 1 multiplied by 1, so it is nothing but P of, and see it is 1 here, but here it would be 2, right? So if I take here, it would be 2, multiplication of a1 a2, I will have 2 here and 2 comma 3, so it is pk, and multiplied by, this is simple, 3 here, it also would be 3, so pj. I guess I have written the correct, yes, p of I minus 1 multiplied by pk multiplied by pj, right? Okay, so so this is nothing but simple generalization of what we have seen for just three elements. If you take four elements, this will also work. There is no problem, right? Because for all elements, we will have like three subset problems of size 3, chain length 3, right? A1, A2, A3, A2, A3, A4. Sorry, just two, right? A1, A2, A3, A2, A3, A4. Yes, just two. Correct. So this is the generalized formula. So let's iterate it one more time, because we have two numericals already, and a high chance of having like one or more, you can say, questions in exam. Sorry if I'm sounding more like a mark guy, but that is what matters right now.
Yes.
Yeah, I might sound like the trend show right now, but pardon me. So Mij is nothing but the cost of multiplying matrix chain from ith to jth elements. That is, if it is M7 10, it is A7 A8 A9 A10. It is nothing but 0 if I equal to j. Right? If I am having just one element, I equal to j. A11 A22 A33, sorry, M11 M22 M33 would be 0 basically. It is nothing but minimum of minimum, I need to take the minimum, right? So after say one point I miss. So we have two problems here, right? If I take this a1 a2 a3, I will have some cost here, some cost would be there, cost one, whatever the I have like 4,000, 5,000, 10,000 appraisals. And if I take this a1 a2 and then a3, then I will have cost 2. So if I want to minimize the cost, what I need to do, whatever the answer is there, C1 and C2, I will choose the minimum one, smaller one, right? So it is nothing but minimum of sorry, minimum of m of ik plus m of k plus 1j plus this, and k is going from I up to j, not j, right? From I to j, I is included, correct? And m of I k, that means from the first element I will go up to kth element, from 1 I will go up to 3. If k is equal to 3, given k, I will break there, take the next take the next problem, next multiplication problem, solve it. M of k plus 1 j, right? So k plus 1, 3 plus 1 is 4, a4 to up to j, plus whatever the cost I have to multiply this element 1 to 3 and 4 to 6. So it is defined something like this: I minus 1, because row would be similar as if I multiplied by a1, multiplied a1, a2 and a3. What would be the row and column after multiplying? It would be similar as number of row I have in a1 and number of column I have in a3, right? Number of row I have in a1 and number of column I have in a3. So it is nothing but p of I minus 1, number of row take from the first element, multiplied by whatever the, wherever I'm doing this split, k equal to 3. So it is nothing but the, if I take k equal to 3, p3 is nothing but number of column in a3, pk multiplied by number of rows, sorry, number of column in this element a6, right? It is pj, right? Once we solve this formula, then this numerical, then this would be very clear. This subset sum problem, I'm not taking it right now. I will have, we will discuss this at last. Okay, let's jump on to numericals, guys. After having just 1 minute of break, we will jump on to this numericals. Solve problem from 2. So these are solve problem, and very interesting one. Very interesting, I must say. This is solve problem, just to give you one more time reference. It is 11.23 to 11.29. In just a minute, we will start. Let me have some water. Yes, Rajesh. What is that video about? You shared some link. You can refer this video if you feel it is difficult to digest.
Matrix multiplication that you were explaining now, you.
Okay, okay.
So, so over there, that instructor has, I mean, he has really represented very well, right?
Definitely.
From
Thanks for sharing.
the
Okay,
formula
Abdul
derivation
Bari sir,
to.
yaar. Okay.
Mm,
He's really good actually. Like the way he talks, like very calm person.
mm.
The
So actually, there
concept
are
of
for
recursion,
DP related
I
activities,
understand
na?
from him. Yes. Sorry.
For DP related training, so for DP related questions, you can, I mean, directly search in YouTube. You will get his videos, and he
Yes, yes, yes.
has very brilliantly explained the things.
Definitely, I learned that more
Mm.
short. One more algorithm I learned that. Then there is really old video regarding recursion call, how the memory is done and how it is there in stacking is done. Like it was brilliant.
Mm-hmm.
Abdul Bari sir
Mm.
is good. Great, great. Thanks for sharing. Actually, thanks.
No problem.
So,
Uh,
Mayur, are we expecting to get any question for LCS to get the LCS between two strings? Like
we
there
had
is one.
right in mid same, I guess.
Okay.
But as I said, like we can solve it directly using pen and paper. No need to apply the that algorithm, because we are doing it actually. Basically, as a human,
Mhm.
we are following that. This is just the mathematical form, like comparing the element. Like take the last element, compare them, note it down, increase by one. So we are doing it inherently.
Okay.
Complex mind we have. Okay, so yes, first question, really good. I guess this question was also there in midsem, not similar one, but there was some this recursive call of a function. Then we want to find out like what would be the last value, right? That's why I was like, I had planned to solve all the problems from mid and mock, midsem exam and mock test in Friday and Saturday. But I guess for on Saturday we need to take like long session, marathon session maybe. Okay, so unsigned integer foo. This is nothing to do with the dynamic programming. This is simple recursion problem. So unsigned integer foo. So I have one function called foo, and it is taking two variable n and r. If n is greater than 0, then it is returning n modulo r, n modulo r plus n modulo r plus function of n divided by r plus r, n divided by r and r, right? Else return 0. If n is not greater than 0, just return 0. Now what is the return value of 4? 345 10, right? So let's try to solve it. I am excited. Yes, control A, delete. So what they are doing is, see how to solve it, just write the function, right? So given the function foo, and what we are calling 345 and 10. Now what will happen? N is equal to 345 and r is equal to 10, right? Now what will happen? N is greater than 0, yes. So else part is gone. Return, what I am returning is n plus n divided by r, and in recursion like state, this want to be written like we will go into recursion tree one by one. After solving all the tree, then we will return something, right? So it will return, so it is returning in the memory, it want to be there on your screen. So n modulo r, so 345 modulo 10, so it is nothing but whatever the remainder we have, so remainder would be 5. Yes. uh okay, it is modulo, okay, modulo 10, no? So 10, how it is 34? Sorry,
34,
it is
right?
5 only. It is 5 only. Yes, 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 yes.
Yeah, yeah,
Why I
5.
am confused, I don't know. I was just seeing my notes. So let's not see the solution. So 4 n divided by r. So if I divide 345 divided by 10, say now there would be a problem if this question is asked in Python, right? Because in Python 2, explicitly you will get integer division. 345 divided by 10 would be 34 only. But in Python 3, it would be 34.5, right? Okay, but see, this is written in C language, or it is looking like C or C++. So it is integer division n divided by r. So 345 divided by 10 is nothing but 34, and r, r as it is. So r is nothing but 10. Now, can we show this on screen? No, because this is one more call, function call. Whenever the function call is made in memory, the function definition is already there, right? Whatever the content we have written in the function, plus parameter is passed in memory stack. So this would be passed to memory stack. This problem is not solved yet. Now what will happen? I will call this 43410. So I need to solve this now, right? Whatever the value I get, let's say I get 5 now, 5 or 10 or 1000. Then I will say 1000 plus 5 is 1005, and I don't have anything in my memory. So let's return and print it on the screen, right? So let's solve this now. 3410. Again, n modulo r, 34 modulo 10 is nothing but 3. Sorry, not 3, 4, no? Modulo. So whatever the remainder it would be there. Thus it is and 4. Actually, I have some problem counting in English. So 4 n divided by r, 34 divided by 10 is nothing but 3, and r as it is. Now what will happen? Again, I will call this function. Just bear with me for a moment. 3 3 modulo 10. So I will have the remainder 3 plus, again I will call the function 4. Now 3 divided by 10 is nothing but 0, right? Because it is integer division, and 10. Now what will happen? Again I have function. This is not done. Now I n equal to 0. N is greater than 0, then this will return this. Else what it will do? It will return 0, right? So there is no more function call. Now what it will do? It will take the stack. It is looking like a stack of book, right? So it will solve from the top. So 0 it will return. So this function is solved now. This function is solved, and I know this is value is 0. So 0 plus 3, it is nothing but 3. So this function is also solved now. I know the answer is 3. 3 plus 4, again this function is also solved now. So the answer is nothing but 7. 7 plus 5, this function is solved now. So I will return 12, and this was the main function call. The answer is 12. right? And this can be like in exam, I guess we had so many recursive call, I guess more than 5 or 6, right? Any doubt, guys? So this is something that we need to solve. We need to break it down up to there is no function, like we don't have any function to solve. We just have the value, integer, float, double, complex, I don't care, any value we have, right? Okay. And if you are not able to find that, and if you think it is running there is no base case or base case is missing or something, just mark not none of the above. Infinite recursive call it will make. Okay. This I am not going into detail because we solved this already yesterday, similar kind of algorithm. T of root n plus n we are having, I guess yesterday we have t of root n plus 1, right? So I guess if we solve that we get log n, sorry, not log n, log n. Okay. So I'm not going into this because there is no point to repeat it again. Okay. Now the main question that we have today is matrix multiplication. Now I have four matrix m1, m2, m3 and m4. Anything can be there, a2, a3, a4, anything. And the dimension pq, qr, rs and st. So what is the dimension of m1? 10 comma 100, 10 cross 100. What is the dimension of m2? 100 cross 20. m3 20 cross 5, m4 5 cross 60, right? So it is matching, pq, qr, rr is matching, ss is matching. So we can have this multiplication chain, there is no problem. Basic check, right? Find the optimal sequence, how to group that, right? Because we have so many possibility. Just group m1, m2, n3 and multiply by m4. Just group last three, and in three we have possibility group first two and last two, right? So what is the optimal subsequence, optimal sequence, not subsequence, optimal sequence for the multiplication of this four matrices, right? So we have this P0, P1, P2, and P3 and P4. I have just written PQ, RST as this because we would be using PI minus 1, PK, PJ like that, right? So I have just converted this PQ, RST value in P0, P1, P2, P3, P4, right? And we have this now. Now, what is the, you can say, SOP to solve this problem is we will just take the chain of 1 first. Then what we will do, we will take the chain of 2. We will try to solve what is the cost of multiplying a1 a2, or m1 m2, then m2 m3, m3 m4, m4, because we will need that in the sub problems of you can say bigger problem. If I want to solve m1 m2 m3, then I need to know what is the cost of m1 m2 and m2 m3. That's why we are solving it in first place, right? Then we will take the chain of length 3, and we have two chains. Then we will solve the last problem, the main problem we have, m14. Why it is main or last problem? Because we have four matrices, m1, m2, m3, m4. And what is the meaning of m14? Mij, that is nothing but multiply matrices from m1 to m4, right? And if you see here, we have say so many sub problems. We need to solve what is the multiplication cost of m2, m3, m4, 2 to 4. What is the cost of m13, m1, m2, m3? That's why we need to solve the chain of 3. And to solve chain of 3 we need to know what is the multiplication cost of m2, m3, m1, m2. That's why we need to solve the chain of 2, chain of 2. And chain of 1 is 0, right? Because we can't multiply, like what is the meaning of m11, right? Do you think this question can be solved using the options? If there is none of the above, then how will you do? I guess we can't solve it using the yes. How, why not, na? We can do that. But the catch would be, if the final cost is this, the minimum cost is, let's say, 500, and given ABC option I am having 600, 700, 800, then you will argue that option A is looking good, right? But that is not the answer, because the minimum cost is 500. So the answer would be none of the above, right? So let's not apply any engineering hack if you have none of the above. But if you have ABCD, then don't be dumb and solve all the problems this thing. Just find out what is the cost of option A, option B, option C, option D, and market. Correct? Okay. Thanks, Virenth, actually giving this idea also. But yes, like in our DNA, we know like in exam how to apply shortcuts. Okay. So this is base case that is solved. When I is not equal to j, let's see. Let's take chain of length 2, right? So how many chain we can have? 3 chains, right? 1 to 2, 2 to 3, 3 to 4. It is nothing but m1, m2, m2 and 3, m3, m4. So what would be the cost of m1 to multiplying m1 and m2? It would be nothing but 10 multiplied by 100 multiplied by 20. So it is nothing but p0 multiplied by p1 multiplied by p2, right? Because the size of m1 is 10 cross 100, size of m2 is 100 cross 20, so the answer would be 20,000. Similarly, what will be the cost of, let's see the last example, m3 4. So I need to multiply by m3 and m4, multiply m3 by m4. So it would be nothing but p2 multiplied by p3, p3 is common in both, multiplied by p4. So it would be 8,000. So I know what are these thing, right? And say from this investigation we know, if we can avoid multiplication of m1 and m2, it is good for our health, right? Because it is costing good for our pocket, basically 20,000. And if we multiply m3 and m4, it is just 8,000, right? So this is good candidate. Okay, let's go one step further. Now we will apply our formula, this formula. Where is that formula? Now we will apply this formula for chain of 3. So if I take chain of length, okay, chain of length 3, then what we will have, we can have only two, this thing, two possibility, m1, m2, m3, or m2, m3, m4. I can have just two possibility, right? And this can be break further into m1, m2, m3, m1, then m2, m3. I can just group first two or last two, like that, right? This is just for understanding purpose. So let's find out, let's solve this, then let's solve this, like which is good, right? Which is good computationally, m1, m2, m3, or m2, m3, m4. Let's find out. So let's take m13. M13 is nothing but our first chain of m1, m2, m3. Okay, so it would be minimum of mik. K would be, so in case of m13, what would be the value of k? What would be the value of k? K is going from I up to j, not j, right? Round bracket I'm having here, right? Let me remove this. Okay, this is LOC, don't cross. Okay, so the k would be I 1, 2, not 3, right? J is not included, I is included. So k I am having 2, right? So I need to solve two problems. If I break my chain m1, m2, m3 like this, m1, m2, and m3, or if I group m1 and m2 and break at the second part, so I can break my chain at 1 or 2, right? So for k equal to 1, say this is k equal to 1, it is removed here, and this is for k equal to 2. So if I take k equal to 1, then my first cost is nothing but m11 plus, it is nothing but mik, m k plus 1, that is nothing but m23, that is the group number 2, m2 and m3, plus joining cost, or you can say the multiplication cost of these two answers. So it is nothing but I minus 1, that is mp0. It is nothing but the row count of first matrix, plus pk, that is nothing but where we are breaking. If we are breaking at 1, then I need to take the column of first matrix, or you can say the column, row of the second answer. So it is p1 multiplied by p3. pj, the column, number of column in the this second term, right? So p0, p1, p3, pi minus 1 k j, right? And similarly, if I take this thing m1 m2, if I group first two, then it would be m12 plus m33. K plus 1 is nothing but 3, j is 3. I minus 1 p0, k pk is nothing but p2, pj is nothing but p3. Now it is trivial. M11 we know, M11 is 0. 0 plus M23 we have already solved. M23 we already solved. It's nothing but 10,000 plus cost of multiplying these two. It is 10 multiplied by 100 multiplied by 3, 5. We know this, right? P0, P1, P2, P3, P4, P5. P4, I guess. Up to P4, yeah. Okay. M12, we already calculated here. 20,000 plus 0, M33 is 0. Cost of multiplying both this thing. And if you take the minimum of both, it is nothing but 1500. Sorry, 15,000. So it is nothing but this thing. If I take k equal to 1, I am getting 15,000, right? So this is good. If I take k equal to 1, so this is good. M1, M2, M3 is good. If I group last two. Okay. Let's solve M24 now, right? How to solve M24 is nothing but M2, M3, M4. Similarly, I can break this in two parts. Either I can take k equal to 2 or k equal to 3. I cannot take k equal to 4. So if I take k equal to 2, I will break at 2. So M22 plus, if I break at 2, the rest of the element M34, and cost of joining it I minus 1 k j. Similarly, if I have k equal to 3, I have this equation. Just put all the value, solve it. Whatever the minimum value you have, it is nothing but the cost of minimum cost of doing M2, M3, M4, right? So it is 50,000, it is 15,000 here, right? So this is good if I take m1, m2 and m3, and it is also good if I take m1 multiplied by m2 and m3, right? So this is solved up to problem chain length of 3, right? Are you following me, guys, or any doubt? Let's take the last one, this m14 now, the main problem we now we will solve. Right, now this m14, if I want to solve mij, that is nothing but m14, I can break it. So for m14, how many value of k I can have? K equal to I can have. So k equal to 1, 2, 3, not 4, right? 1, 2, 3 I can have. So what happen if I take k equal to 1? Then this, it will look something like this. Keep m1 as it is, group last 3, right? Breaking from first, you can say index, not index but first location, first matrix. If I take k equal to 2, then it will look something like this. Break here, m1, m2, m3, m4. And if I take k equal to 3, then it will look something like this, right? And see, we have already solved this. What is the cost of m24? 50,000. What is the cost of m12? M34 we already solved. M13 we already know, 15,000, right? Now after grouping all this, we will know like what is the minimum cost, right? It is about to 11, I guess. We are on time. 11, I thought it's 12. Okay, so m14, it is nothing but I need to write three equation: k equal to 1, k equal to 2, k equal to 3. So if I take k equal to 1, I will break at 1, so it is nothing but m11, next element, rest of the element 2, 4, 2 to 4, right? And the cost I minus 1 j k j. Similarly, if I take k equal to 2, then I am like counting from I 1 to 2, rest of the element 3, 4, 0, 2, 4, I minus 1 j k j. Similarly, if I take k equal to 3, I get this equation. And this all we have already solved. 2, 2, 4, 1, 2, 3, 1, 2, 3, 4. All this we know. And after multiplying all this thing and taking the minimum cost m14 is nothing but 19,000, and it is for, I guess, the last this thing m13 and 44, right? So m13, the cost is 15,000, and minimum cost is 15,000. M13 multiplied by m4, so this is the best case, right? So they can ask for a chain, so we know this cost 19,000, right? So how can we now know like what is the answer? So let's trace everything back. So how do we get this 19,000? 4k equal to 3. What is k equal to 3? It is nothing but m1 m2 m3 into m4. Okay, so m1 m2 m3 is 15,000, right? But when it is best, m1 m2 m3, when it is best? So it is best when I take k equal to 1. This case, right? If I take k equal to 2, then it would be around 25,000 or 30,000. So k equal to 1, it is best. So I will take k equal to 1. What is the meaning of k equal to 1? Break here. M1 multiplied by M2 M3, and M4 I had already outside. So this is the final answer, right? So this is the optimum way of doing the multiplication. Multiply M2 and M3 first. Whatever the answer you get, multiplied by M1. Whatever the answer you get, last multiplied by M4. Then you will just need to perform 19,000 operation, right? And see how you can say bad it would be if I take this case. Just multiplication of 3 would be 3 would have taken the 50,000 operation, right? And if I see here, it would be really tough, right? The answer would be, see, 50,000 plus something, 1 2 3 4, so 80,000 more, 8 and 5, 1 lakh 30,000 operations I need to do in worst case. I'm not counting for this, but worst case, right? So where we have like 1 lakh 30,000, and where we have this 19,000 only, right? So this is the problem, right? We have one more problem in exercise, and what we have now. So these asymptotic notations, I am not taking it. We will solve all the mandatory exercise problem. This is the solved problem that were given in the class, right? Okay. Merge sort, take this much of thing and this much of thing. Okay. Okay. So I guess we are done with this thing. We will now solve this mandatory exercise uh, from 23. This thing. How many questions we have? Six or seven? Seven questions we have. It is 11.30, right? Okay. Any questions, guys, for this Matrixian multiplication? Because if you understand it thoroughly, this is really beautiful, because we are solving it one by one, and at last we are having really beautiful result, right? We are able to identify what is the best case, correct? I guess the formula is now making some sense. I k k plus 1 j I minus 1 kj. Understood?
Mayur, do you think such questions will come now because they have removed
Definitely,
the
it was already there
difficult
in
questions?
exam.
Okay, but these are lengthy questions, na?
Huh. In medium, they can ask, no. See, I was explaining that way it was looking like a lengthy question, but if you think, these two things are very common, right? So basically, you need to solve for just three problems: M13,
Hmm.
M24, and 14. Correct? Okay, so let's take this mandatory exercise problem. And I want to discuss this actually. This question is like catching my eye. Uh, So this was really good problem in solved example that is not there in mandatory, or I guess in mock it is not asked. But this is really good. So merge sort takes 30 seconds for input size of 64. How many numbers it can sort in 6 minutes, right? So if I have size of 64, it is taking 30 seconds, right? So there is some rate, right? That 64 input in 30 seconds. So 128 input and 1 minute, like that, correct? But it is not like that, right? You can make guess something like this: in 30 seconds it is 64. So for 128 it will take 60 seconds. No, it is not like that, because merge sort time complexity is n log n. If it was linear, then it is possible, right? Because at first time I was not getting to understand even after seeing the solution, but now I understand it, that time is proportional to input size, right? Some bit of mathematics. Time is proportional to input size. There is some proportional, right? N1 log n and like that. So t1 divided by I1, so if I take the ratio, then it would be constant, right? That's how this is defined. right? Correlation is defined. So T1 upon I1 is nothing but T2 upon I2, input size, right? So given input size N1, this ratio would be similar, right? So given the input size, what would be my time complexity? And it would be N1 log N. And for second case, it is N2 log N. It is same thing, right? Same, you can say, merge sort algorithm. Now what they have given is, for 30 second it can process 64, size of 64, right? So for 30 second it is 64. Now they are asking how many number it can process in 6 minute, that means 360 second. So 30 divided by n1 log n equal to 360 divided by n2 log n. I guess it is solved in different way. They are trying to find out the constant first, then multiplied by n2 log n and divided by 360. We are doing the same thing, nothing fancy. But this would be really easy because we don't care about the constant now, right? So we are removing some steps, right? The 64 is given. We need to find out n2. 30 divided by 64 log 64, 360 divided by n2 log n2, right? And solving this thing is a bit tricky, but after solving up to this we can just take the options, just take like whatever the option is given. If it is given 512, just put 512 multiplied by log 512. If you are getting 4608, we are good, right? So 30 divided 64 log 64 into log n2. I will just make this as the principal. So it is nothing but 360 multiplied by this. So I will get n2 log n2 equal to 4608, right? And there are so many methods to solve this. But one method is a multiplied by log b is nothing but log b to the power a. So I have done the same thing, right? And if you want to remove the log, you can take the exponential, right? So it is nothing but e to the power l and x is nothing but x. So I've taken the exponential on both sides. So I need to just factorize this thing, 2 to the power 4608, like this. The n2 multiply n to the power n2, some number to the power same number. So if I factorize this one by one, then I get 512 power 512, and here I have n2 power n2. So n2 is nothing but 512, right? But definitely this would be easy to solve from the options, because we know n2 multiplied by log n2 is 4608, right?
Mayu, did they mention that this problem, I mean, this is the time taken by recursion?
Ah,
Because there
they
is,
said na merge sort takes 30 seconds for input size of 64.
no, merge sort can be done by recursion and even by
No. See, recursion and
recursion and normal if else, and there is different time complexity for that. One is order
no.
of n
See,
and
whenever we are talking about any time complexity of given algorithm, we just take the average case, right? And the average case would be n log n, because I can write a program like a very bad program and it would
Average
be
case
n
or
square.
worst case?
Huh?
Average case or
Worst case,
worst
right?
case? We should take worst case, right?
Worst case, no, worst case.
Yeah,
Yes. Worst case,
worst
yeah.
case.
Here we are taking worst case. I just got confused
no,
between
then
Professor Khalil comment.
no, worst
Yes,
case is
worst
then
case.
order of n. Merge actually merge sort can be. I mean, if you go through the videos, you can clearly understand that merge sort can be done by two different methods. One is using, I mean, without using recursion, and one is using recursion.
Okay.
So with recursion, the time complexity is n log n, and without recursion, it is just order of n.
Okay, order of n only.
Hmm.
Oh,
And
that's
that
beautiful.
piece is missing over here, right?
Order of n, is there any algorithm like which can do the sorting
Order
in
of
order of n?
n, I don't think so. Merge sort is order
No.
of n.
Order of n merge sort cannot do, no, because we are
Right,
dividing
because you can.
everything in two parts, no. Then we are solving.
Uh, okay, I'll go through the videos again and
Sure,
I'll
no
send that
problem. That's
particular.
fine.
Uh,
Because I guess there is no algorithm which can do sorting in order of n. Because in
insertion
order
sort
of
is
n, we are
there.
just checking the elements one by one, right?
Yeah, insertion
So
sort
intuitively, it
works.
is not possible. Like by checking all the elements once, if you can sort it, it would
Yeah,
be great.
insertion sort also if all the
Elements are
elements are in
sorted.
ascending sorted.
Best
Yeah,
case, just ignore actually every time.
yeah. We
Hmm.
should also always consider the worst case.
Hmm.
Order of big O. Sorry, big O.
Hmm. Sure, no problem. But see, we need to take this worst case time complexity, and average, I guess it is not discussed in our content also. So worst case time complexity we can take for merge sort n log n, and we can solve it, right? The best guess actually we need to make, right? There were so many questions in mid sem 3 also, like 2 to 3 questions that we need to take the best guess. Like we cannot perform feature engineering and we cannot do this and that like that. Okay, let's jump on to the mandatory exercise. It is 11:05. Mostly by 11:30 we would be able to finish this. A list of n strings, each of length n, is sorted into lexicographic order. And if this question is there in exam, I will just keep it because I don't know what is lexicographic at first place. I need to use the dictionary. Using the merge sort algorithm, the worst case running time complexity of this computation is, right? So what they are saying is list of n strings. So I'm having n strings, and each of length n, right, is sorted into lexicographic order. So no, in lexicographic order, what does it mean is nothing but the order that we have in dictionary, right? So if you see in dictionary, the first letter first would be sorted a b b b b b like this. Then the second letter would also be sorted. So A B would become for like it would be on like come you can say earlier, then AC, then AD. And if it is tie, AD and AD, I will go for the third letter. If it is A here, it would be first. If it is B, right? If it is again tie, I will go for fourth letter, right? So it is nothing but the lexicographic order. Now, what do we have? We have this thing, this n strings, n strings, and the length is also n, right? And it is solved using the merge sort. So what is the time complexity of merge sort? Let's assume it is n log n. So how many problems that I need to solve? So what I'll do, I will take the first letter and sort it. So how much time I will take? N log n, yes or no? Now it is sorted something like this, a b b b c c c, like that. Now again I need to sort this thing, the second letter also, right? Then again I will take the same time n log n, and how many times I need to do? N times. So multiplied by n log n plus n log n plus n log n times is nothing but n multiplied by n log n. So it is nothing but n square log n, n square log n. The answer is n square log n, right? uh, do I have take any example? Yes, right. So what I'm doing is I need to sort first I need to sort n this first you can say later, then second later, then third later, fourth, then five. That's the total n time I need to do. N log n time is nothing but n square log n, right? Second is, I guess, from the answer is simple question. What is the worst case time complexity of merge sort? If all elements are given in the ascending order, right? If it is in ascending order or descending order, in merge sort, if you think intuitively, it doesn't matter, right? Best, thus the best, average, and worst case time complexity is n log n, because given any type of array, what we are doing is we are dividing it into half. So how many division would be there? How many time divide I will do? Log n time, right? Log n time, why? Because n would be divided in n by 2, then n by 4, then n by 8, like that, right? So it is nothing but log n time, and I need to merge them, right? So that merging operation is order of n. Every time I need to do merging. So order of n, order of n, order of n, and log n time. So it is nothing but n log n, right? So what is the worst case time complexity? Is n log n again, right? But the hack we can have here is, before applying merge sort, just check once if it is already ordered or not, right? It will take just order of n, right? Just to check. a1 greater than sorry a1 a1 less than a2 less than a3. We just need to check once, right? Then apply merge sort. Then you can definitely eliminate this worst case, correct? Is anyone want to say something? I can hear some noise, that's all. Yes, now it's good. Thank you very much whoever was there. Okay, question number 3. In a modified merge sort, the input array is split at position one third of the length n of the array. Okay, one third we are doing the split. The recurrence relation to present this modified merge sort. Recurrence relation is nothing but this equation, recursion equation. So, what it would be? So, given array of n, I am just making. You can say I am just dividing it at one third place, right? So n by 3 element I will have here and 2n by 3 element I will have here. So this is merge sort, right? So what I need to do, I need to solve this t of n by 3 problem. I need to solve this problem also t of 2n by 3, and I have divided them, right? I have divided them at any stage, right? I need to merge them also. So what in what is the time complexity of merging? It is nothing but order of n plus n, right? At any stage, the merging time would be order of n only, right? Because we have that those two loops, and in order of n, it would be able to merge them, right? In order. So the answer is t of n by 3, t of 2n by 3 plus n, and I guess it is not there in any case. So it is you can say none of this, right? Okay. Uh, Correct option. Why it is looking something like this, different color? Okay, so you have n list, each consisting of m integers sorted in ascending order. Merging this list into a single sorted list will take how much time? Right. So how many list I am having? N list, and how many integers in each list? It is nothing but m integers, right? And it is already in ascending order. Cool. And I am performing the merging operation. So how much time it will take? Let's see. Where is the answer? Yes. So I'm having n list of m like this, right? So how merging operation is performed is, we will take the pair, right? In pair. In merging operation can be done in two parts only. We have array 1, we have array 2, we will merge them, right? So now what I have, so now to merge this, how much time do I need to do is, so if I take at first level, see at one pair I am having m, that means nothing but n list I am having, right? And if I have just one pair, right? M and m. So m is nothing but number of element in it, right? 3 and 3. If I take how much iteration I need, I just need 6 iteration to merge them. So it will take m plus m, that is nothing but 2m time, right? So now this is nothing but the ground truth we know. Let's solve the problem now. Now at first level, how many pairs I will have? After I have this n list, total count is n. So if I make the pair of 2, how many pairs I will have? N by 2 pairs, right? And what would be the cost? N by 2 multiplied by 2m. It is nothing but m n. Again, m multiplied by n, right? Because cost of solving one pair is 2m, right? At second level, how many pairs I will have, right? So I have n2 pairs. I will make group of 2. So n by 4 pairs I will have. What is the cost? N by what is the odd here? It should be n by 4 here. There is a problem here. It would be n by 4 multiplied by 2m plus 2m. M. So 2m plus 2m is nothing but 4m. This 4 and 4 will cancel out. So I will have n m. So here it should be n by 4. I have problem here. N by 4 to 2m plus 2m. So it is mn again, right? And at kth level, right? At kth level, it would be n divided by 2 raised to k pair, and the cost would be again same m into n, right? So the total cost is nothing but the number of levels I am solving. It is nothing but k levels multiplied by the cost mn 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 m multiplied by n. Now I need to know what is k, and when will I stop? When I will have no pairs. Like if I have just one array, right? One array, nothing to merge. If I have two array, I can merge it. If I have one array, whom will I merge, right? So n by 2k equal to 1, 2k equal to n. So k is nothing but log n, right? K equal to log n. So if I put log n here, the answer would be m into n into log n, m into n into log n. It is nothing but order of m n log n. Right? Good question, right? Okay. Question number 5. Any doubt, guys, in question 4? Or we are good?
Yeah,
Cool.
my if in case the m integers are not sorted, then what could be our answer to that?
See, if it is not sorted, you are asking.
I mean, yeah, yeah. It's
And
they said that.
actually, it doesn't matter, no. It doesn't matter, actually. And why? See, see, and they are asking for merging only, right? They're not
Yeah,
asking for dividing. So it doesn't matter if it is in ascending order or not. Whatever the list we have, see, whatever the two list we have, we can merge it in order of n, right?
yeah.
I
Okay,
guess you remember this, right? If we have 2, 6, and let's say 3, if it is not sorted, na, that's also fine. 9, 8, 11. Correct? I will have just two pointer and will sort it. I will have the length of 6 and it would be sorted. Correct?
okay, okay. Yeah, yeah.
Mayur, I was just thinking in the other way. Like I thought initially looking at the question, since the single merging cost only big O of n, and we have only n less than m big O of n. I was thinking that way.
Still, I'm not able to get you. Can you be please more louder?
So the single time complexity for only merging is big O of n, correct?
Ah,
And I was just thinking like, okay, I'm wrong. Got it.
no, no, why you are saying you are wrong? You have not
No,
asked
no,
the
no.
question.
I was thinking in a different way. Sorry. I found what was wrong in my thinking.
Okay, okay, no problem. Self realization, great. Okay. So, so why? I guess you were asking why we are multiplying by n. If that was the question, if it is not, because we have this much of pairs. That's why. This is just one pair. We can have so many pairs of 3, 3, 3, 3 like that. Then we will have 6 and 6. Then we will again merge with 12. Right? That's why this merging is working. Correct? Okay. And there is no problem if they are saying it is in ascending order or not. Because we don't care. Let's see here. And yes, these questions are also asked that we won't ask this in exam because this two-way merge sort algorithm is different than simple merge sort algorithm, right? Let's say my answer is also wrong. Then I learn Abdul Bari sir lecture. Please watch for the two-way merge. He explained what is merge sort. Then he explained what is two-way merge sort. I guess he started with two-way merge sort only. So what is two-way merge sort is we can have two-way, three-way, k-way. So what two-way merge sort is doing? See, in simple merge sort, what we do is we divide by half. Then again we whatever the answer we get, we again divide by half both sides. Then again we divide by half until we have one you can say element each. Then we will start to combine them. Combine this and this. Whatever the answer we get, not this and this. Okay, this and this, whatever the answer we get, 2 and 2 we will again combine by 4. Similarly we will combine 2 and 2, again we will combine by 4, then we will combine these two and we will get the sorted array. This is simple merge sort, right? Let's see the mentos or two-way merge sort. So two-way merge sort works something like this. Let me show the diagram here. So two-way merge sort is we will divide our array in the pair of two, right? I will take first two, next two, next two, next two. If one is remaining, I will keep it as it is. No problem. We will merge them, right? We will merge it at anyway, right? So two-way merge sort is nothing but oh, here I have also written check two-way merge sort by Abdul Bari. Great. So 20, 47, 15 I am just dividing my array in pair of two, right? In case of two-way merge sort. Right now, what I'll do, one first I have like divided everything, then I will merge them. Right. So this is nothing but the first pass. It is called first pass that I'm passing my array. Right. So first pass is nothing but dividing into pair of two. Right. Second pass, what I'll do, I will merge them one by one. Right. So the merge, if I merge this thing and this thing, then it would be sorted. First 8, then 15, 20, 47. Right? Then in second pass, this would be the answer. So it is there 4, 9, 30, 40, 12, 17. So second pass, this is sorted. Correct? So that's why this is the answer. In third pass, I will merge this. In fourth pass, I will, I guess, as per algorithm, I need to go up till end. So I will merge this. So in fourth pass, this 6 would be sorted, and at seventh part, everything would be sorted. Right? The simple, you can say, flavor of merge sort algorithm, two-way merge sort. But I guess this was not taught in syllabus. Okay. Uh, and if you apply simple merge sort, na, then you will get the different answer. Okay. Second last question. Beautiful. Okay. The repetition of Matrixian multiplication. And again, the answer is similar. Is it exact repetition? Literally, it is repetition, or we have different value of p0, p1, p2, p3, p4. Right. So what they've given is given the dimensions p0, p1, pn corresponding to matrix sequence a1, a2, an, where ai has the dimension p of I minus 1 pi. That is nothing but if I say a3, what is the dimension? P2 multiplied by P3. P2 cross P3, right? So I Pi minus 1 Pi. Determine the multiplication sequence that minimizes the number of scalar multiplications in computing A1, A2, A3, A4 such that P0 is this, P1 is this, P4 is this. Determine how to parenthesize the multiplications, right? Till date, I am not able to understand this graph. If someone decode it, please like share it.
If
Like
there are four options like this, we can directly calculate from the MCQs, right?
there
It
is
will
no
not
options.
waste time. If there are options like these, we can directly calculate from the options, right? Like
Definitely,
multiplying,
definitely. Let's
rather
try
than
that.
going.
I would love that.
Yeah, I also tried that directly.
Huh, we
I
can
got the
do that,
answer.
right? Definitely, we
Yeah.
can do that. So, what is the cost of A1, A2? Actually, we don't need anything. A1, A2, it is nothing but 5 so is 120 multiplied by, now I need to multiply the answer of a1, a2 and a3. So it would be nothing but 5 multiplied by 6 multiplied by this 2. So 35 to sign. Am I doing
Mayur,
right or wrong? Huh.
I think we can the cost
Skip.
of multiplying a1 into a2 we can just find it by using this diagram that they have shown.
Huh.
So a1 a2. So where is one on the
See,
j side?
up to 120, 40 and 84, it is same simple multiplication of a1, a2, then a2, a3, a3, a4.
No,
This
it's
88,
like
I don't know. I guess this is the minimum cost that we incur. But how to? I guess this is simple answer they have given. We can't solve using this kind of pyramid, maybe.
that is not pyramid actually. That is matrix, but that is half part of matrix.
Ha ha ha. How to derive this 88? I guess this is the
So
answer. I
this
know, like this is minimum cost that we will need. But from 120 and 48, we can't get this.
no, that's for that derivation and the formulas that you had given.
Huh, that,
Okay, with
that
that,
we need to
so
solve.
that formulas will tend to this. answers. And
Yes. Yes, yes, yes. 88 we are getting here. See, the minimum of cost of
minimum
multiplying
of this,
1 to 3. 1 to 3. So 1 3 it is 88.
it,
That's for sure. But I thought like this is kind of a, you can say, method to solve these kind of problems. But I guess we can't.
no, no, that is matrix. With your formula only they have solved it, but they have placed only half matrix,
Yes,
half
yes,
part
yes,
of
yes,
the
yes, yes,
matrix.
yes, yes. So this is the answer directly, right? There is nothing method. There is no method that we can apply. Shortcut, right? Uh,
There
method.
is no shortcut. We need to solve it by using the method
Formulas
that you had
only.
said.
Yes, yes, yes. Huh. And if this kind of have we have this for options, none of the above is not there, then we can directly solve the cost of A, cost of B, cost of C, and then we can mark the answer. Right? Okay. Yeah. Anyone has any doubt or want to see, like, want to solve this again, or we can move to last question. It's your call, guys. This matrix multiplication, this book is already there, so feel free to like solve it. And if you have any problem, you can refer this. 3.4. I just renamed everything for subject 1 in Drive also. Okay. The last question, very intuitive one. Suppose you have a rod of length 10 and you want to cut up the rod and sell the pieces in a way that maximizes the total amount of money you get. A piece of length I is worth of pi dollar. See, if the wood, right? So if it is 1 feet long, it is pi dollar, $1. If it is 2 feet, it is $7. 3 feet, $11, like that, right? Determine the value obtained by cutting up the rod and selling the pieces, right? And now I have the rod of length 10, right? I have 10 feet rod. If I sell it directly, then how much money I will get? $30, right? But if you think here, if I is it possible that if I cut it and in a way that I can earn more dollars, right? Correct. So what would be that way, right? So how to solve this problem, right? And if you go in this thing, what is that called, brute force approach, then it would be hectic, right? Because how to find out the number of possibilities. Number of possibilities are 10, you can say, wood block road of size 1, 5 block of 2, or 3 block of 3 and 1 block of 1, right? 3 2 and combination of 1 2 3, 1 2 3 4, combination of 5, combination of 6, right? So how to solve this, right? So what I will do, and see, this is nothing but the market price. If it is 8 feet, it is 20. But if I'm having a rod of length 8, I can maximize the profit, right? By selling two pieces of 4. 12 plus 12, it is 24. And who knows, like there is a different, you can say, combination that will maximize my profit. So how to solve this kind of a problem? So basically, in this is some out of context, but basically if you have any dynamic programming question, this kind of a question that you need to solve bigger problem, then think something like that. Just take the smallest problem, base case, that is trivial. Then what we will do, we will solve one by one problem. It will take less time. Believe me, if you take all the combination of brute force, it would be terrifying, it would be pathetic. But if you solve from smaller problem, then it would be good. So we can apply. What we will do, I will do. What I will check. What is the maximum dollar I can earn for the length of like 1 feet, $1. How many like maximum dollar I can earn if I have length of 2. So if I cut it, it would be $2 only, right? If I don't cut it, it is $7. So don't cut it. Maximum is 7. What is the maximum for 3? What is the maximum of 4? Right? So the maximum of 4 is nothing but maximum of 2 plus maximum of 2, right? Or maximum of 1 plus 3, right? So I need to know what is the value of maximum profit that I can earn out of a 3 feet long road or 3 feet wood, right? So what I'm doing, I am just going one by one from the very trivial case. If I have length of one, it is $1, and I'm going like in sequence. I will solve one by one, and at last I would know the answer, the maximum profit I can get with the 10 feet long road, right? And we don't have anything in this PDF. I That's for sure, because if it is there, I would have remember it. See, just this diagram is really good, but after that, it is pure mathematics and programming, right? So let's see how to solve this. I hope I have written this. Yes. Now, what we'll do, and see in this table, I am. This is memoization. This is not trivial. We are just having one dictionary. If I talk in terms of programming, so this is the cost that we know for the length of 1 2 3 4 5 up to 10, and this is the maximum price that we can earn, right? Maximum revenue that we can get if we have length of 6, length of 5, length of 4, any length we have. So for length of 1, it is trivial, it is $1. If I have length of 2, what are the cases? 1 or 1 or 2, just two cases, right? So if I take 1 and 1, I will just earn 2 rupees or $2, right? Or if I just solved it whole, I'll get 7. So max is 7. So the maximum revenue I can get is 7, right? Maximum earning I can get. L equal to 3, I have three possibilities. 1 1 1, it is 3. 1 and 2, it is 8. And only 3, 11. So max of everything is 11. So maximum profit I can get is 11. Now the interesting part will come. So if I have 4, length of 4, I can have 4 possibility: 1 1 1 1, 2 2, 1 3, or 4, right? So max of 4, 7 7. If I solved it in 2 and 2, it is 7 7. 1 and 3, 1 plus 11, 1 plus 11, 4, it is 12. So max of everything is 14. So maximum profit is 14. If I if I sell the part of 2, right? 2 and 2. Similarly, for L equal to 5, I am just ignoring this length of 1 because it is very cheap, right? So I have 2 3 1 4 or 5. So maximum is 18. So I have solved for 5 also. Similarly, for 6 I can solve 1 5 2 4 3 3. Right? 1 5 2 4 3 3. Sorry, 2 and 4 I have missed, I guess, here. 2 and 4, 21. I have missed that part, 2 and 4. Right? That combination I have missed, but you got the idea. Maximum would be 22. Right? And why this is useful is because to solve 10, I can have this much of part: 1928374655 or 10 only, right? And I cannot use the price directly. For let's say I'm having 8, sorry, 2 and 8, right? So I cannot use this price directly. 2 is 7, 8 is 20, because the maximum profit I can earn out of 8 is nothing but 29. How? So we have already solved. Just solve 3 and 5 or 4 and 4. Part of 3 and 5 or 4 and 4. Right? And maximum profit by earning to earn like having 4 is nothing but is I don't need to solve the 4 directly. I need to break it again into 2 and 2. Correct? That's why these small problems that we have solved for length equal to 2, then 3 and 4, everything sums up and it solves the bigger problem, L equal to 10, right? The answer is 36. And the combinations are so many, and I guess it is repeating also. So the first combination, this is just for time pass. I had some spare time, so I have written it, and now it is beautiful. So if I take 5 and 5, and how to earn the maximum profit for 5, it is nothing but 2 and 3. 2 and 3, 7 plus 11, I will get 18. So it is 2 and 3. So 2 and 3, 2 and 3. So it is 2 2 3 3. Right? 2 and 8. If I divide, I have two possibility. Again, if I divide, I will at last I will get the same, you can say, answer: 2 2 3 3. Correct? So if I cut my rod into this like four, you can say, pieces, I maximize my profit. Maximize my profit. Right? Any questions, guys? This could be tricky, but with solving some number of problems, you will realize like how to address that. And this idea I got from the coin change problem. Given a knot, how can you how many ways you can change? How many ways you can arrange a coin, right? To have the change for given knot. Okay, guys. So I guess we have done as planned. We have done 2 days of proper practice in notations, recursion problem, dynamic programming problem, and I am skipping this last part. The subset sum problem. It is just the sexy thing about it is nothing but it is complex class. You cannot solve it less than exponential time complexity. Nothing fancy about it, and the formula is there. But I guess this formula is also you can say trivial, right? So you can just say this, and if you have any questions or any query, we will take it like tomorrow. It is 11:36 already. That's why I'm winding it up. Any questions or any query, guys, or any suggestions, anything?
Mayur, I mean, if you have time, I have one thing. I
Sure.
mean, I did not understand one thing. Can you come back to the assignments?
Assignment. This thing,
Correct.
huh?
Sixth question. Show me the sixth question. No, wait. Wait. Up. Fifth. Fourth.
Fourth question. Amen logic.
This one.
Huh.
I know you had spent much of your time on this, but still.
Huh. That's fine. I have no problem. I almost sleep at 12:30, so that's fine.
So this really I did not understand. I even watched it properly, but
Okay. No problem. I definitely repeat it. No problem at all. Question number four. No, five. No? Recursion and DP exercise. Okay, not this one. This one. Assignment problems. No. Yes. One, two, three, four. Yes. Now what they've given is we have m list, or you can say m arrays of m arrays of size m, and how many of them we have? N list. Such n list we have, right? Let's see the problem first. Question number 4. We have n list, each containing of m integers sorted in the ascending order. Right? So I have I have n list. Right? Let's take 8. Right? So I have n list. Right? And each of size m. Right? Each of size m. Now what will happen? Now I need to do, you can say, merging. Right? And now what is the cost of merging m and m? Two list. It is nothing but 2m, because I need to go through each element once in both the list. So it is nothing but the cost is 2m, right? Now at first pass, what will happen? I will merge this, this, and this. So how many merge operation I am performing? 2m, 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 2m. So it is nothing but 4. First I had 8. Now I have performed 4 merge operation. So it is nothing but n by 2. N by 2 merge operation I need to perform. Are you following me, Rajesh?
yes, Mayur.
Right now, how many merge I need to do? Four total. Sorry, here I need to perform these two. I need to merge this and merge this. So how many I need to perform? Two merge operation
Mhm.
I need to perform. So it is n by 4. And what is the cost of merging this and this for m? And what is the cost of merging this and this? It is also for m, right?
Hmm.
Correct. Have
Yes,
I
Mayur.
made any mistake here? Okay, that's fine. 4m and 4m, so it is 8m. So at each stage, how many? So if I have n such you can say slice, so how many times I am performing n by 2 multiplied by this 2m, right? So it would be again 2m. See, here I have taken 8, right? So it is nothing but if I divide by 2, it is 4 operations I need to perform of size 2m, right? So it is nothing but 4 into 2 8, 4 into 2 8 m, so total 8m, right? 2m 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 2m. So again at third stage, how many time I need to perform, how many operations I am performing? 8m. What is 8? 8 is nothing but n, right? So that's what we have generalized here, right? So at first level I am having n by 2 pairs. Out of n I am having n by 2 pairs. The cost is nothing but n by 2 multiplied by cost of 1. Cost of one pair is nothing but 2m, right? So 2m multiplied by n by 2 is nothing but m plus m into n. At second level, n by 4 pairs I will have. N by 4 pairs I will have. 2 pairs, right? 8 divided by 4 is nothing but 2, right? And the cost is nothing but 2m plus 2m, or you can say 4m. 2m plus 2m, 4m. N by 4 multiplied by 4m, there is a typo here, right? There is a problem here. N by 4 multiplied by 4m is again m into n, right? So at each level the cost is nothing but m into n. So at kth level it would be n divided by 2 raised to k pair, and cost would be m into n. And when will I stop? When will I stop? When I have just one pair. That means the array is sorted. If 4m and 4m is sorted, I have the array of 8m, right?
Mm.
So I will stop here. 2 divided by 2 is nothing but 1. It is nothing but n divided by 8. 8 is nothing but this thing, n only, right? So 8 divided by 2 raised to k is equal to 1. So 2 raised to k equal to n. So k is log n, right? So the total cost is nothing but at first level mn, second level mn, third level mn, kth level mn. So total cost is k into m into n, right? And what is the value of k? Log n. So the total cost is m n log n. Is it clear?
Mm-hmm.
Huh?
Got it.
Sure, sure. Any
Thanks for
more
it.
guys, more doubt, guys? Uh, okay, guys. Then thanks for joining the session. A bit late. It's a bit late, but thanks for joining. I